Welcome to this first tutorial on artificial intelligence. Let's begin with a quick question. Have you noticed technology anticipating your needs? Think about the last time you got a perfect movie suggestion. Your grammar checker instantly fixed a sentence, or a chatbot explained a concept in seconds. That's artificial intelligence, AI, working behind the scenes to make tasks faster and your life easier. In this short video, we'll define AI, explore its main types, trace its history, and see how it's shaping both academics and professional life. To start, let's define AI clearly. AI is a machine-based system that, for goals defined by humans, makes predictions, recommendations, or decisions that affect real or digital environments. In other words, it's software that can process data and act in ways that seem intelligent. Unlike traditional software, AI can adapt its behavior based on data. Now that you know what AI is, let's look at one of its most important parts, machine learning. Machine learning means a program improves its performance at a task when it gains more experience. Think of a spam filter. The more emails it sees, the better it becomes at sorting junk from real messages. In other words, the system learns patterns, like phrases or senders, and then sorts new emails automatically. Chances are, you're already using AI every day without even realizing it. When you ask a voice assistant to set a reminder, when a chatbot helps you with a quick answer, when a translation app makes an article readable in another language, or when a writing assistant suggests a clearer sentence, those are all real-world examples of AI at work. These aren't future ideas, they're tools you already use. Next, let's explore the main types, by scope and by behavior. Let's start explaining AI by scope. By scope, we have narrow AI, which is designed for a specific task, like voice assistants, recommendation systems, or route planning. This is actually the AI we use today. There is general AI, a system that could perform any intellectual task a human can. But general AI is still only theoretical, we don't have it yet. We can also describe AI by how it behaves. Let's start explaining reactive machines, which only respond to the present situation. A famous example is IBM's Deep Blue, the chess system that beat Garry Kasparov in 1997. It played brilliantly, but it didn't learn from past games. Then, we have limited memory systems. They use recent data to make better decisions. For instance, parts of self-driving cars rely on recent frames of sensor input to steer safely. A newer idea you'll hear about is foundation models. These are very large systems trained on broad data. Once trained, they can be adapted for many different tasks, like answering questions, summarizing text, generating code, or even tutoring. ChatGPT is an example of a foundation model in action. Now let's take a quick journey through AI's history. AI has a history stretching back more than 70 years. Here are 5 milestones that shaped the field. In 1950, Alan Turing proposes the imitation game, now called the Turing test. In 1956, the Dartmouth Conference coined the term artificial intelligence. In 1986, the backpropagation algorithm made training deep neural networks practical. In 2012, AlexNet shocked the research community by dramatically improving image recognition. And in 2017, the Transformer architecture was introduced, powering today's modern AI systems, like GPT. History shows how we got here, so how is AI used today? In academics, AI supports writing with grammar and clarity tools, provides study help with practice questions and translations, and assists with research by summarizing articles or helping organize data. But it sometimes generates hallucinations, plausible but false content, so always double-check and cite original sources when it comes to study and tutoring. AI can create practice questions, explain concepts, or translate texts. In terms of research workflow, AI can summarize articles or generate code snippets. But you must keep track of where information comes from and verify it. Let's take a moment to meet Aisha, a researcher at a prestigious university in London. She uses AI to polish her methods section. She then checks every claim against the original research, adds proper citations, and includes a short AI use statement in her paper. Moving on using AI, In professional contexts, we can already see how AI is boosting customer service with chatbots, supporting knowledge work by making writing faster and more accurate, and improving healthcare through AI-enabled medical devices. Experiments reveal that AI can help people complete writing tasks faster and with higher quality. In the field of healthcare, the FDA maintains a public list of hundreds of AI-enabled medical devices, signaling how quickly AI is entering clinical practice. But with these benefits come responsibilities. AI can generate errors, show bias, or raise privacy concerns. AI can also raise issues of bias and fairness. If the data overrepresents some groups and leaves out others, the system's decisions can become unbalanced or unfair. That's why organizations like NIST recommend a clear framework: govern, map, measure, and manage. Also, the U.S. Department of Education reminds us that human oversight, transparency, and equity are essential. For you as a student, the message is simple: verify the facts, cite your sources, and always follow WU's policies for AI use. In closing, AI is not a replacement for your thinking. AI is already part of how we study, work, and live. It can be a powerful collaborator, helping with brainstorming, first drafts, and pattern recognition, but it is not a replacement for human judgment. Your role is to stay in charge of accuracy, ethics, and final decisions. By understanding how AI works, its history, and its applications, you can use it wisely and responsibly, both in your studies and in your career.